Hello and welcome to Lesson 4.4, Triangle Congruence, SSS and SAS. And we'll talk about what those stand for here in just a little bit. As a reminder, this video will only cover Lesson 4.4. In your note packet, we've combined Lessons 4.4 and 4.5, but this video will get you all the way through Example 4a at the bottom of that page, and then the next video will cover the remainder of Lesson 4.4, 4.5. So start by doing the warm-up, please. Give yourself a few minutes here. You may need to pause the video as I will continue to show these answers in just a second. But go ahead and do the warm-up, and when you are ready to check those answers, click play. All right, here's what we should have. Name an angle formed by ray AB and ray AC. They both share a vertex A. So we could say just angle A or angle BAC or angle CAB, but A should be the middle letter if you use all three. I want you to name three sides of triangle ABC. Those would be AB, AC, and BC, with segment lines above each one. And if you would also name all the pairs of congruent corresponding parts of these two triangles. Well, we have sides QR is congruent to LM, RS congruent to MN, and QS congruent to LN. And angles Q and L are congruent, R and M are congruent, and S and N are congruent. All right, I think we're ready to begin. Once again, make sure that you have done all the vocabulary, at least for Lesson 4.4. In your vocab book, there's not a whole lot you have to fill in the notes. We've given you a lot of that. But make sure you have read Lesson 4.4 before watching the rest of this video. I think it'll make a lot more sense. All right, if you're ready, though, we will start with Lesson 4.4, Triangle Congruence, SSS and SAS. We will be applying SSS and SAS to construct triangles and solve problems, and we will prove triangles are congruent by using SSS and SAS. In the previous lesson, 4.3, you learned how to prove triangles are congruent by using the definition of congruent triangles. In that case, you had to show 6 different things: 3 pairs of congruent corresponding angles and 3 pairs of congruent corresponding sides. Well, what we're teaching in this lesson is a way to bypass some of that due to triangle rigidity, which is a vocab term. And I've given you the definition in your note packet of that already, but this is a reminder of what it is. Triangle rigidity gives you a shortcut to proving two triangles are congruent. Rigidity means fixed or solid, not able to be changed. And so the fact that a triangle cannot be moved around, it will retain its shape, gives us this idea, and we can take some shortcuts. All right. If the side lengths of a triangle are known or are given, the triangle can only have one shape. That's what triangle rigidity says. Triangle can only have one shape if the triangle's side lengths are given to us, means they're fixed in that relationship. For example, you only need to know that 2 triangles have 3 pairs of congruent corresponding sides. This can be expressed in this postulate. And SSS stands for side, side, side congruence. And in a proof, we will only have to write SSS as our reason when we have proven triangles are congruent using side, side, side. And here's what that theorem states. If 3 sides of one triangle are congruent to 3 sides of another, then the triangles are congruent. So we are actually able to take a shortcut and not have to prove that all 3 angles are congruent to the other 3 angles in the other triangle, whenever we can just show that 3 pairs of sides are corresponding congruent sides. Remember, adjacent triangles share a side, so we can apply reflexive property to get a pair of congruent parts. So let's take a look at example 1a. We're going to use SSS to explain why these 2 triangles, ABC and DBC, the one on the left and the right, are congruent. We're not actually doing a formal proof, we're just writing an explanation. So here's what we should say. It is given, these markings in red are given information. It's given that AC is congruent to DC and that AB is congruent to DB. By the reflexive property, BC is congruent to itself. These 2 triangles share that same side. So that is where our third pair of congruent sides comes from. So we can say triangle ABC is congruent to triangle DBC by side, side, side. So why don't you try and word this next explanation the same way. If you need to go back and look at how that was worded, that's fine. But look at what you're given. We're given AB is congruent to CD. We are given AD is congruent to CB. And notice that they share a side. So remember why AC would be congruent to itself. Write an explanation and check and see if it looks something like this. Pause the video if you need more time. Okay, this is what we should have. It's given that AB is congruent to CD and BC is congruent to DA. The top and bottom sides are congruent. The left and right sides are congruent. By the reflexive property of congruence, again, you can write that as REFL period POC. By the reflexive property of congruence, AC is congruent to CA, or if you wrote AC both times, that's okay. So the triangles are congruent by side, 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 because we've shown 1, 2, 3 pairs of congruent corresponding sides. Side, side, side congruence. All right, now, as you'll see in this diagram here, this isn't something directly given to you in your notes, but it is our next theorem I want us to talk about. Triangle rigidity also works if you know about an included angle. This is a new vocab term for you. All right, it's something you should write down in your vocabulary notebook, but there's not a place for it in the note packet. An included angle is an angle formed by two adjacent sides of a polygon. Remember, adjacent means next to or in a row. So in this case, angle B is the included angle between sides AB and BC. It's between. Included angles are between two sides. All right, so we have side AB and side CB or BC that include this angle B here. All right, angle B is between these two different sides, or it's made up by these two different sides. So it can also be shown that only two pairs of congruent corresponding sides are needed to prove the congruence of two triangles if the included angles are also congruent. And this is where we get SAS, side angle side congruence. The angle has to be the included angle between those two sides. All right, so if I have two sides and the included angle of one triangle, side AB and side AC, and angle A, the included angle, side, angle, side. If those are congruent to two sides and the included angle of another triangle, side, angle, side, then the triangles are congruent. So we can take another shortcut. We don't even have to say all three sides if we know one angle of this triangle is congruent to the same corresponding angle in this triangle when those are the included angles. The letters SAS are written in that order because the congruent angles must be between the pairs of congruent corresponding sides. So let's use that to do example 2a. This diagram shows part of the support structure for a tower. Let's use SAS, side, angle, side, to explain why these two triangles are congruent. All right, so here's what we have. We're given that XZ is congruent to VZ, and YZ is congruent to WZ. Now, the included angle between these two sides is this angle here at Z. The included angle between these two sides is here at Z. What kind of angle pair are these two angles at Z? If you said vertical angles, you are correct. Remember, vertical angles are congruent. So that's why the included angles are congruent here. So this is what we could write. It's given that XZ is congruent to VZ and that YZ is congruent to WZ. By the vertical angles theorem, angle XZY is congruent to angle VZW. And we have to use all three of these letters here and here because there's multiple angles at the same vertex Z, so we need to be specific. Therefore, triangle XYZ is congruent to triangle VWZ by SAS, side angle side. The way that you write these letters is important. Remember, congruent corresponding parts must line up in the same position in this statement. So let's try part B here. We're going to do something very similar on part B. It's a little bit different diagram though. Let's look at the given information. AB is given to us as congruent as DB. These two sides are congruent. They have marked the angles congruent. And then the other side that includes both of the angles on top and bottom is the side BC. See if you can tell me why BC must be congruent to BC. If you said the reflexive property, you are correct. So we are given that the included angle is congruent to the other included angle, and that AB is congruent to DB, and by the reflexive property, BC is congruent to itself, so these triangles are congruent by side angle side. you should have something written like this. It is given that BA is congruent to BD, and angle ABC is congruent to angle DBC. By the reflexive property of congruence, or reflexive POC, BC is congruent to BC, so triangle ABC is congruent to triangle DBC by side angle side. The side angle side postulate guarantees that if you are given the lengths of two sides and the measures of the included angles, you can construct one and only one triangle. That means only one distinct triangular shape. You can draw it several different times, but they will always be the exact same size and shape. So let's take a look at example 3a. We're going to show that the triangles are congruent given this value of the variable. Now, notice you're given 3 side lengths here and expressions for 3 side lengths here. Which do you think we're going to use? Side, 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 or side angle side? If you said side, 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 you are correct. Let's take a look. We know PQ is x plus 2, so we substitute 5 in for x. 5 plus 2 is 7. PQ is 7. It must correspond, if you look at this order, PQ would correspond to MN. Well, MN is 7. Let's look at QR. QR is x. Plugging in 5 for x, QR is 5. QR corresponds to NO. NO is also 5. PR is 3x minus 9. Plugging that in, 3 times 5 is 15. 15 minus 9 is 6. PR, this bottom side, is 6. Well, the corresponding side on the other triangle is also 6. So we can say PQ is congruent to MN, QR is congruent to NO, PR is congruent to MO, so we have side, side, side congruence. Triangle MNO is congruent to triangle PQR by side, side, side. Your problem in your notes needs to show all of this. Alright, let's see if you can take a few moments to try and work this one out, and I will give you some heads up. We want to show that these triangles are congruent when t equals 4. So let's look at what we're using. We have 2 sides marked here, and then the shared side, DB, and then an angle measurement. Since we're using an angle measurement, you're going to use side angle side. You want to show that AD and DC are the same thing when t is 4. Obviously, DB would be congruent to itself, so you want to show that what the value is when t is 4 for this angle and this angle. That's the only other part. So take a few moments to plug those in and see what you get. This is what we should get. Again, if you need to go back and pause or pause now to copy this down, that's fine. Here's what we have. DA is 13 when you plug in 4. DC is 13 when you plug in 4, so they are congruent. The measure of angle D for BDC is 2 times 16, which is also 32 degrees. So these angles are congruent by definition of congruent angles. DB is congruent by reflexive property, and DA and DC are congruent by definition of congruent. So the triangles are congruent by side, angle, side. Okay, and in our last example for this video, we are going to do a proof to prove that 2 triangles, ABD and CDB, are congruent using either side, side, side or side angle side. So let's review what we're given. We are given that BC is parallel to AD. That's what these lines mean. And BC is congruent to BD. So we know we have one pair of congruent sides. You see that they share side BD, so there's another pair of congruent sides. But the parallel lines will tell you that alternate interior angles are congruent by the alternate interior angles theorem. So we're using the included angles. This means we will use side angle side to prove the triangles are congruent. So let's look at what we should have first. Starting with the first given, they just choose the first given this time. We have BC is parallel to AD. That is what tells us that the alternate interior angles CBD and ADB are congruent by the alternate interior angles theorem. So we have our included angles marked as congruent. Statement 3, go back to that other given. BC is congruent to AD because it's given to you, so there's a pair of congruent sides. So we have side angle taken care of. Now we just need to say that BD is congruent to itself by the reflexive property. So there's the other side. We've shown side, angle, side congruence. So we can say triangle ABD is congruent to triangle CDB by side angle side, and you'll see that they cite this order of the steps, 3, 2, 4. Make sure you've done that. This is something we'll review a little bit more in class. And as I said, we will get to the rest of these notes later, but this does wrap up our video for lesson 4.4.